All right, so in this video, I'll be going over some indirect proof practice problems. I'll start out with a little mini lecture about how indirect proof works, but then eventually I'll move on to some practice problems, and hopefully this gives you some practice and some preparation for the indirect proof problem that will be on the final exam. There will be only one, but you will need to complete it to get full credit for the final exam. I hope this is helpful. So indirect proof works a very specific way. And essentially what you do is you'll have your premises, one, two, let's say there's only two. And we won't really fill out what's in these premises because it doesn't matter for this basic sketch of what indirect proof does. So whatever you have in your premises, you'll have a conclusion, and let's say your conclusion is X for a certain argument. With indirect proof, it's going to start out like conditional proof. If you haven't watched the video on conditional proof, make sure to do that as well. But indirect proof is going to let you it's another way to prove an argument or to prove a specific proposition to be true, but the way we'll be using it is we'll be using it to prove our conclusion to be true. Now, the way this works is this. Like conditional proof, you'll start out leaving a little bit of space between your line number and what you're going to write, whereas with direct proof, we usually just write things right here, like you would write P, if P then Q right there, just to save space. But we're going to leave a little bit of space for indirect proof. And with conditional proof, you saw that we would assume the antecedent that was in the conditional in our conclusion. In the case of indirect proof, what we're going to assume is the opposite of our conclusion. So in this case, our conclusion was X. What we're assuming instead is not X. So we will assume not X, and in our justification, where we'd write our rule, we'll write assume, or I like ASSM as an abbreviation. And you don't have a line number, but you have to say what kind of proof you're assuming it for. So we'll just write IP. Let me lower, so we can lower the boldness on the line. So we're going to start off with not X. And unlike in conditional proof, where we are trying to demonstrate the consequent to our conditional that's in our conclusion, with indirect proof, what we're trying to do is find a contradiction. So we're going to go down. Again, I don't have any premise lines here. This will become more clear in the practice problems we go through. But eventually, as you're working through indirect proof, you'll eventually find some terms, and you'll find two contradictory terms. That is, some term and its opposite. A contradiction is something like P and not P. If you're using simple propositions, you may run into something like not C or D and not C or D. That's also contradiction because you have a term, a positive term, and the opposite of that term. And you may remember from our discussion of truth tables that a contradictory proposition is one that is not possible in any possible worlds. It's impossible for it to be true. And because it's impossible for something to be true, then it can't be true in our argument. So what we've done in line 3 is we've assumed not X to be true. And from assuming not X, we've shown that there is a contradiction that follows, such as P and not P. So when we discharge our assumption in an indirect proof, what we do is our final line, we put the contradictory terms into a conjunction with one another. In this case, P and not P. And what we put in the direct proof, after we bracketed off our subproof, our indirect proof, we put the opposite of what we assumed. So here we assumed not X. The opposite of that is just X. And how fortunate for us, X is our conclusion. X is the thing we're trying to prove. So you see with indirect proof, this can be a very helpful way to prove a conclusion to be valid, because if you use indirect proof in this way, you can always show your, assuming the argument's valid, you can show your argument to be valid because once you discharge your assumption in the indirect proof, you're going to get your conclusion because you began by assuming the opposite of your conclusion. This doesn't always work for every kind of argument, and you can use indirect proof as a subproof alongside steps of direct proof in your argument. That's far beyond what we're going to cover for this class, in this class, and for the final exam. all you'll need to do is apply indirect proof as I have, where you begin by assuming the opposite of the conclusion and then go on your merry way using our natural deduction rules until you find a contradiction. So let's demonstrate this concept with some practice problems. So let's start out here with practice 1. Our first premise is if T, then A or B. Our second premise is not either A or C. And our third premise is B if and only if C. Our conclusion is not T. So we're going to begin this proof for this argument the same way we will for any indirect proof, and that is, again, by assuming the opposite of our conclusion. Our conclusion here is not T, so the term we're going to assume is the opposite of not T, which is just positive T. We'll write our justification step, assume for indirect proof. And now, once we have T by itself, we can go on applying T with any of the premises and any of our rules that we've learned, as we would a normal natural deduction problem. Again, we're going to end our indirect proof once we find a contradiction. So let's go on as if this were a normal proof. So in line 2, I see that we have not A or C, and I know that with a De Morgan's step, is using De Morgan's rule on line 2, I can get not A and not C. Now, the key thing about with these indirect proof methods of solving a proof is that you're almost always trying to find a contradiction between simple propositions. That's how you should be thinking about this. So you should always be thinking about trying to use inference rules in order to break down these complex propositions. You may need to use some replacement rules to allow you to use the proper forms of your inference rules. But by and large, once you see a possibility of breaking down a complex proposition, you should take it. So here in line 5, we have not A and not C. And this is a very easy opportunity for us to apply our simplification rule, right? Simplification lets us break down a conjunction into its constituent conjuncts. So I'm going to get not A on line 6 and not C on line 7. Both of those we're just simplifying from line 5. Now, additionally, that T we began by assuming is going to help us out as well. We'll see in line 1, we have a conditional. If T, then A or B. So using line 4 and line 1, with modus ponens, we can get A or B. That's great. I'll even star line 1, telling me I've used up that line, so to say. And even line 2 we used to get that De Morgan's of not A and not C. So now all we have left is this biconditional on line 3, B if and only if C, at least as far as our complex propositions are concerned. Well, that is except for the A or B we just got on line 8. So we can break down that one very quickly. We have A or B, and if you want to break down a disjunction, you need to use disjunctive syllogism. In order to use disjunctive syllogism on that disjunction, you need the opposite of one of the disjuncts. In this case, we have that. In line 6, we have not A. So something has to make that disjunction true. It's not going to be the A part, it must be the B part. So we use disjunctive syllogism on lines 8 and 6, and that'll have us break down that A or B. Now, in line 3, we have that biconditional. Now, this is a pretty easy one because whenever we see a biconditional, we know there's only one rule we can use there, and that's material equivalency. So we'll have if B then C, as well as if C then B. And that is material equivalency. That's a replacement rule, so we only cite one line, line 3. Let's make some more space now. So whenever we use material equivalency, obviously we're using it to break down a biconditional, but once we get that biconditional broken down, usually, and this is a strong usually, there's only one of these conditionals that we need to get to the end of our proof, at least for the proofs we'll be covering for this sake of our class. And this requires a little bit of thinking ahead. Now, if we pick the left conditional, if B then C, notice we have the given form of the antecedent B on line 9 and the opposite form of the consequent, not C, on line 7. So we'll be able to use modus ponens and modus tollens for that. By contrast, if we were to simplify and get if C then B, the right conjunct there, we wouldn't be able to use either modus ponens or modus tollens with the information we currently have. We don't have C by itself, and we don't have not B by itself. So while we're allowed to simplify this and get both conditionals, only one of these is going to help us out, and that's going to be the if B then C conditional. That's, again, using simplification on line 10, where we had a material equivalency pop up. So we have if B then C, and you actually have two options here. You can use either modus ponens or modus tollens, and you're going to end up with a pair for our contradictory pair. I'm going to use modus ponens because it's a bit more intuitive. Most people like modus ponens over modus tollens if there's no negation flipping or anything like that. So in line 9, I have B, and in line 11, I have if B, then C. So if I use modus ponens on those lines, then I can derive C. Notice now, here I'll switch to the highlighter, we have not C in line 7 and C, which is its opposite, in line 12. There we found a contradictory pair, C and not C. So we can join those in a common line conjunction with lines 7 and 12. And now I'll zoom out a bit to capture the full force of this proof. Now we're going to discharge our assumption, put that bracket there. Again, we're going to end our indirect proof with that contradictory conjunction, C and not C. And once we go to the direct proof in line 14, we're going to write the opposite of what our assumption was. Remember, our assumption here was T. We showed that if you assume T, you end up with a contradiction. So T can't be true. And if every proposition must be true or false, it must be that T is false, which is just another way of saying that not T is true. The way we cite that is by writing IP lines, and then we put a line range, the same way we did for conditional proof, not individual line numbers. So there is how you would complete number 1. I'm going to move on now to some more practice problems. And as always, if you have any questions, feel free to ask them in the comments, and I'll try to get to them. But I will keep moving on through these. So here we have another argument, and this one's actually only going to be a one premise argument. Our premise is A and not B, and from that, presumably it follows not A if and only if B. So there's our argument. Now we need to show with indirect proof that this argument is valid. So what we're going to do is the same thing that we do for every indirect proof, is we begin by assuming the opposite of the conclusion. Our conclusion here is not A if and only if B. So the opposite of that is just to take off the negation and make it A if and only if B. And again, we're not deriving that from anything. We're just assuming it. And I always want to write C for conditional proof. We're assuming it for indirect proof. You have no conditional here. Well, we have a biconditional. And now we can move on using our normal deduction rules. So we have two options. We could start by simplifying line 1 or using material equivalence on line 2. We'll do both of these steps, but it doesn't matter at the moment which we do first. So we already have this biconditional here. I'm just going to simplify it. That is to say, break it down using material equivalency. B arrow A. And that's material equivalency on line, not line 1, line 2. Remember, again, material equivalency is the only rule you can use for a biconditional. So, use it when you see it. So now we have if A then B and if B then A. And as I mentioned with the previous problem, usually we only want one of these conditionals. We don't not quite know just yet which one we want. You may be able to look a bit far ahead and see. But first we should break down that line 1 using simplification. And that'll give us a bit more insight as to which of these conditionals we'll end up wanting. Again, there's no problem if you simplify and get both of those conditionals and end up not using one. It just makes the proof more elegant. That is, it uses fewer lines if you don't have any unnecessary lines in your proof. So we have A and not B on separate lines. Now we can ask which of these conditionals in line 3, if A then B, or if B then A, is going to help us, are we going to be able to break down using what we have in lines 4 and 5? So I see for the first conditional, if A then B, I would need A by itself or not B by itself. And in fact, I have both of those in lines 4 and 5. Whereas if I wanted to get the right side conditional, if B then A, then I would need B by itself or not A by itself. I don't have either of those. So again, in this case, we're going to use the left-hand conditional, if A then B. That's another simplification step on line 3. And now we're going to end up using both modus ponens. Well, actually, no, we only need to use one of modus ponens and modus tollens. Similar to the last problem, it doesn't matter which one you use here, as long as you use the rule correctly. We'll do modus ponens this time because we used modus ponens last time. So here, look at lines 5 and line 6. We have a conditional, and we have the opposite of its consequent. That means we can deduce the opposite of its antecedent. In this case, that would be not A. So that's modus tollens on lines 5 and 6. And now we see we have A in line 4 and not A in line 7. So we're going to conjoin those now that we found a contradiction. Bracket off our subproof, our indirect proof, lines 4 and 7. And then back in the direct proof, we shifted away from the centered or right shifted text. Now we're going to the left. We're going to write the opposite of what our assumption was. Our assumption was A if and only if B. The opposite of that is just not A if and only if B, which is the conclusion of the argument we were trying to prove the whole time. So there we have a very similar but slightly different use of indirect proof for this one. Let's move on now to a third practice problem because we're having so much fun with these already. So for this third one, we have in our first premise, if A or B, then X, then A if and only if not B, and then for our conclusion, we have X or Y. So we're going to start this off the same way we do any indirect proof. We start by assuming the opposite of our conclusion. Our conclusion here is X or Y, the opposite of which is just not X or Y. So assumption for indirect proof. Great. Now we can go on using our normal inference rules. So in line 3, we have a negated disjunction. That screams to me, use De Morgan's law, right? Because whenever we can use De Morgan's law to get a conjunction, a positive conjunction, that means we're close to breaking down a complex proposition into its smaller parts, which is exactly what we want for indirect proof, especially. So that was De Morgan's on line 3. And now we can simplify this, get not X on one line. And we can get not Y on its own line if we wanted to. But notice that not Y or any form of Y is not showing up in any of the premises in 1 or 2. So we're allowed to get not Y by itself. We can do that on a separate line, but we won't need it to progress in this proof. So I'll leave it out. So we have not X, and I'm thinking, okay, where can I use this not X that I just derived? Well, in line 1, we have a conditional with the opposite of not X, that is X, as the consequent in this conditional. I have the opposite of the consequent in a conditional. That tells me I can use modus tollens. So on lines 5 and 1, and for using modus tollens, I can get the opposite of the antecedent in that conditional. So the antecedent up in line 1 is A or B, the opposite of which would just be not A or B. So now I have not A or B, and I'm thinking the same thing I thought in line 3. A negated disjunction. Let's just use De Morgan's to turn that into a positive disjunction. And the reason I want to do that is because I can then use simplification to break that down. I can get not A on one hand and not B on the other hand, which is great. I got some simplification. I got some single terms, some simple propositions in there, not A, not B, and not X. And I can even star here in line 1 to show that I've used modus tollens to break that down all the way. And now all we have left as far as complex propositions go is line 2, that biconditional. Again, if you have a biconditional, there should only be one rule that comes to mind, and that is material equivalency. So we make a conjunction between two conditionals, the conditionals going each way. If A, then not B, as well as if not B, then A. That was material equivalency on line 2. And again, we're going to be forced to pick one of these. In this case, we're actually going to want the right-hand conditional, and we'll see that once I write it out. Right? If we have a conditional, we're thinking to break it down, we need modus ponens or modus tollens. We need either the opposite form of the opposite form of the consequent, which for our case would be not A, which we have, or the given form of the antecedent, which would be not B, which again we have. So we're going to be allowed to use modus ponens or modus tollens to get to our conclusion here, or to get us to the end of our proof, that is to say. So let's just go back and forth. We did modus tollens last time, so let's use modus ponens this time. In line 9, we have not B. In line 11, we have if not B, then A. So that tells me I can get A. That's using modus ponens on lines 9 and 11. Now, let's make some room here for the end of our proof. Now, I see I have not A in line 8 and A in line 12. I'm going to end by putting those into a conjunction, A and not A, lines 8 and 12. I'm going to bracket off that subproof and then discharge my assumption. So I notice that I began by assuming not X or Y. Well, I've shown that to entail a contradiction, so I have to derive the opposite of that assumption, which in our case would just be X or Y. That was using indirect proof on lines 3 through 13. So that's just another argument using indirect proof. Let's move on now to a fourth one. So for this problem, we'll start out in premise 1. If A, then C and D. In premise 2, if B, then, I lost it, not C or F. And our conclusion is not both A and B. Some different symbolization. Not both A and B. So we're going to start out this proof the same way we do any indirect proof. We start by assuming the opposite of the conclusion. Our conclusion is not A and B, so we're just going to assume A and B, plain and simple. An assumption for indirect proof. That's a P. Great. So now we can go on using our normal inference rules. So I have a conjunction in line 3. The first thing I want to do is simplify that and get A by itself and B by itself. And that gives me two simple propositions. Maybe these will be parts of the contradictory pair that I end up finding, who knows. But at least I have A by itself and B by itself. So what might I do next? Well, I see for each of these, I can use modus ponens, A with line 1 and B with line 2. So it doesn't matter which we do first. We'll need to do both. We'll just go in order. So line 1, if A, then C and D. We have A on line 4, so we'll derive C and D. That was, again, using modus ponens with lines 1 and 4. Well, now I have another conjunction. I might as well simplify that one too. So C, simplifying from line 6, and D, simplifying from line 6. Great. Now I can go to line 2 and do modus ponens there with that B in line 5. That'll get me not C or F. Now, we can't do anything with this immediately, but notice it's a negated disjunction, which means we can use De Morgan's law to change it into a positive disjunction, which in this case will be not C and not F. That was De Morgan's on line 9. Now we have not C and not F, and we could derive not F if we wanted to, but really all we want here is not C, using simplification on line 10. That's because, as you'll note, we already had C here in line 7, and now we have the opposite of C in line 11. That's our contradictory pair. Let's put them into a conjunction with one another, C and not C. Conjunction on line 7 and 11. Now that we've found our contradictory pair, we'll close off our subproof and discharge our assumption by writing the opposite of our assumption. Our assumption was A and B. The opposite of that is not A and B. And we figured that out using indirect proof with lines 3 through 12. So another classic use of indirect proof. Let's do one more of these. Here, number 5, we have as our first premise, if B, then F or D. In line 2, or premise 2, we have not if A, then F. In premise 3, we have if A, then not C or D. And in our conclusion, we have not if A, then B. Great. So we're going to start this the same way we do any indirect proof, is start by assuming the opposite of our conclusion. Our conclusion here is not if A, then B, the opposite of which is just positive if A, then B. There we go. And again, we assume that for indirect proof. Now we can start applying some of our deduction rules. Now you'll notice immediately that we can't use any of our inference rules. Line 3 is a conditional. We don't have any of its, you don't have the antecedent or the opposite of the consequent. Line 2 is a negated conditional. We don't have a rule for that, but we'll be able to manipulate that a bit. And line 1's a conditional, and we don't have B or the opposite of F or D. So what we'll need to do is use a replacement rule to flip at least one of these around. The first thing I see is line 2. So line 2 is a conditional, but it's a negated conditional, which means if we use material implication to turn that conditional into a disjunction, that'll give us a negated disjunction, which we'll then be able to use with De Morgan's to turn into a positive conjunction. That had a lot of thinking ahead involved, so let me break it down like this, and here on the side it will help. So currently in line 2, we have if A, then F. Using material implication, we can get that to not A or F. And then using De Morgan's, we can get that to A and not F. So to get there, we used material implication, and then to get there, we used De Morgan's. And then once we have A and not F, we can get A by itself and not F by itself. And that'll help us with the rest of the proof. So that's one of those difficult things to see at first. Um, you see a negated conditional and you think, well, there's no rule for me to use here. There's no rule for you to use there to break it down, certainly. But with some of our replacement rules, you can then turn that into a conjunction that you can then break down. So let's apply those rules more formally in our proof. So, and going from line 2, the negated conditional, to line 3, which will be our negated disjunction, let's write this here, not A or F. That was material implication on line 2. Then we can use De Morgan's law to change that to A and not F. You may want to look at the paradigm for De Morgan's law to see how exactly we did that, which terms we flipped the truth value on, and flipping the or to an and, the V to an ampersand. That was De Morgan's on line 5. So now we have A and not F, and we can just simplify both of those. I think we're gonna need both of those for the rest of our proof. Simplification on line 6. Simplification on line 6. Great. So now we've got this A and this not F, and let's see if we can plug those into our other lines. And we'll star line 2, line 6, because we broke that down. So it looks like in line 3 we have if A, then not C or D, and we have A on line 7. That's a pretty easy use of modus ponens, so let's do that. Modus ponens, lines 7 and 3. Not C or D. Again, we have a negated disjunction. That seems to scream to me, hey, let's use De Morgan's and turn that into a positive conjunction. On line 9, I can then break that down into not C on one hand and not D on the other. We may need both of these, we may not, I'm not quite sure, but I'm just going to simplify both just for convenience here. So let's keep line 1 in sight. We still haven't done anything with that. We can mark off line 3 now that we've used modus ponens on it. And all that remains for us that I can see is line 1. Now notice that we have in line 4, if A then B, and in line 7, A. Well, that itself is a pretty easy modus ponens for us to get B. Now you may, let's finish this line before I say all that stuff. 7 and 4. Now you may have seen that in line 4, we have if A then B, and in line 1 we have if B then F or D. You also could have used hypothetical syllogism here to get if A then F or D. That's a perfectly fine thing you can do. The weird thing about hypothetical syllogism is it often doesn't actually cut down the number of lines you need in your proof, or the minimum number of lines you can have in your proof, other than using modus ponens twice. For some of them. So in this case, we won't use hypothetical syllogism, but if you wanted to use that as your solution, that's perfectly fine. You can do that. But now we have B by itself. And in line 1, we have if B, then F or D. So again, using modus ponens, again, with lines 13 and 1, that'll get us F or D. So now we have an option. We know, so line 14 seems to be saying that one of these things has to be true. F by itself or D by itself, maybe both. But we'll notice in lines 8 and 12, we have not F and not D, respectively. So we can use disjunctive syllogism here with either not F or not D, and we're going to end up with a term in our contradictory pair. Doesn't matter which. Here I'll just pick the closest one, which is the not D in line 12. So taking line 14 with line 12, we can deduce F using disjunctive syllogism. And now we can conjoin that F from line 15. Let's highlight it. F with the not F in line 8. 8 and 15. And that is our contradictory pair to end our indirect proof. So we'll bracket that off, make a little bit of space. Line 17, we write the opposite of what our assumption was. Our assumption in line 4 was if A, then B, the opposite of which is not if A, then B. We showed that using indirect proof on lines 4 through 16. So those were a couple practice problems for indirect proof. As I've tried to show, this one isn't as difficult to master, I think, as conditional proof. For this one, it's really just using the same rules we use for direct proof, but instead of finding the conclusion in the subproof, we're finding a contradiction, putting that contradiction on the final line in our subproof, and then by showing that a contradiction entailed from our assumption, which was the opposite of the conclusion, we can derive the proper form of the conclusion and thus prove the argument to be valid. Again, if you have any questions, feel free to email me or post a comment below, and I'll try to get back to them as soon as possible. Thanks for watching. Best of luck studying.